This is the first time I've been introduced like that. It sounds like I'm on the Tonight Show or something like that. Hi, everyone. I think it's not the afternoon yet, right? I think after this we have lunch. So my name is Yongpradit. I'm the Director of Education at Code.org. Code.org is a national nonprofit that promotes computer science education around the nation. It's actually had international reach as well, but our focus is establishing computer science in every single school in this nation, all, I think, 140-ish thousand schools, K through 12, public and private. So you can tweet me at Mr. Yongpradit, which is a long last name, but I think you could probably find it in the brochure as well, and at Code.org. I'm going to start off with a video that explains a little bit about what Code.org is about. Raise your hand if you've heard of Code.org before. Wonderful. Okay, so this is a video you've probably never seen. It's kind of based off of that initial video from 2013, the one that hit #1 on YouTube for a day, which is pretty amazing for a video about computer science to hit #1 on YouTube for a day. But let me show you a 1-minute version of that.
Here we are, 2013. We all depend on technology to communicate, to bank, and none of us know how to read and write code.
The first program I wrote asked things like, what's your favorite color? Or how old are you?
I wrote a program to play tic-tac-toe.
I first learned how to make a green circle and a red square appear on the screen.
You're just trying to make something, trying to transfer something from your mind to the computer or to a tablet it's an experience.
The whole limit in the system is just that there just aren't enough people who are trained and have these skills today.
The programmers of tomorrow are the wizards of the future. You know, you're going to look like you have magic powers compared to everybody else.
Great coders are today's rock stars. That's it.
So I've yet to get to meet any of those famous people. But I did get to meet Vint Cerf recently. Vint Cerf is one of the fathers of the internet. Him and I believe the other guy's name is Bob Kahn, I believe. But Vint is a vice president in Google, and Google has an office in this area, Western Virginia. I'm from Silver Spring, Maryland, so even though Code.org is based in Seattle, I work in Silver Spring. So if we have any DC area folk here, I'm in your area. Let's chat sometime. I want to start off with a picture of what this presentation is all about. It's about students. So most of us here are either teaching or involved in education some way. Maybe you're an administrator. This is a picture of my 7th period AP Computer Science class from 2 years ago. I taught at Springbrook High School for a number of years. Springbrook High School is a high school in Silver Spring, Maryland, which is a suburb of DC. And before I came, the computer science program was in trouble. There weren't enough kids who were interested in computer science, and there wasn't enough opportunity for all the students who were interested to even take it. So we built a program basically from scratch, and in my last year we had 2 AP computer science classes, 2 teachers teaching computer science, and probably about 9 or 10 computer science classes overall. And so this is a very interesting picture because, not just because it's a computer science class in a high school, and the majority of our high schools actually don't offer a computer science experience. Even in Montgomery County, which is one of the wealthiest counties in the nation, I believe up to last year, I think 6 or 8 of the 25 schools, high schools, didn't offer computer science. So if you were a student in one of those schools, you just simply could not take computer science. But other than having a computer science course at all, this is a pretty interesting picture because of the different ages, races, and genders who are represented in this picture. And this is a pretty special class, so special that there were many athletes who took computer science in this class, and actually all of the athletes were the girls. So if you look at the front row, they're the ones wearing the uniforms, and the guys are not wearing uniforms. So it's a very special class. And like I said, unfortunately, you won't find many computer science classes in high schools around the nation, and they certainly, if you do find them, don't look like this. So this is my personal dream, that when you walk into a computer science class at the high school level or even at the middle school level or elementary school level, but really at the high school level where it's an elective, you don't just see the usual suspects. So our vision at code.org is to bring computer science to every single school because every single student deserves the opportunity to learn computer science. And so today I'll be talking about why is computer science important, and I believe that some of you guys really don't need convincing, but I'm going to talk about it anyway because you might need to convince other people. So I'm going to equip you with the key messages behind the computer science education movement. And so we believe that every single school should have computer science because every single student deserves the opportunity in the 21st century. And the idea is to create students, to equip students who are not just users of technology and not just creators with technology, but creators of technology. And so a lot of us here are familiar with the EdTech movement, so just the use of technology in education across the board, whether you're in a techie class like computer science or English. So a lot of us are familiar with EdTech. EdTech is creating with technology. What I'm talking about is not EdTech per se, it's creating the actual technology. So rather than using an app in a biology class that helps you examine a frog's anatomy without getting your hands dirty, I'm talking about actually creating that app. And that's what computer science is about. We have 3 pillars at computer science. They are to educate, advocate, and to celebrate. We celebrate computer science by holding events like the Hour of Code. Raise your hand if you participate in the Hour of Code. Wonderful. So the Hour of Code, guys, for those of you guys who participated, it's basically the world's largest learning event ever. But lots of folks still don't know that and still haven't participated in it. And I'm glad that you did. So the Hour of Code is under our celebration pillar for computer science. There are learning outcomes attached to the Hour of Code, but really they're mostly about exposure and motivation. So in terms of exposure, of the millions and millions of kids who did the Hour of Code this year, 48% of them were girls and 52% were boys, which is absolutely amazing in the field of computer science, and you'll see why later on. Other than the Hour of Code, we also shoot a lot of videos, like the video I showed you, depicting people from different ages, races, genders, and also walks of life, like Chris Bosh from the Miami Heat, who I believe is either a power forward or center for the Miami Heat. He studied web development in college and was part of a special club for it as well. And he was made fun of, but he liked it a lot. And so we actually shot a video of him explaining functions and procedures in programming. We do a lot of advocacy work as well. So at code.org, we're a very holistic organization. We don't just approach it from one particular avenue, we look at the whole problem. And a lot of the problems in education revolve around policy, right? And I don't know if you guys know, but right now Congress there's a lot of debate around the reauthorization of the Elementary School Education Act, which in its last iteration was known as No Child Left Behind. So that's actually happening like right now, and it's very hotly contested, and a lot of us really, I don't think a lot of us are being asked for our opinion. And it's funny how the news cycle works. If there's anything about the presidency, which is like the presidential race, which is still like a year and a half away or so, it's hot news. But if there's something about the ESEA, you get it maybe on the second or third page. So I implore you to find out a little bit more about the ESEA and that reauthorization through your different unions and speak up because it's going down right now. So advocacy work, we do a lot of promotion of state-level policy that supports computer science education, like making computer science part of the core discussion around computer science rather than the elective discussion. And so basically, in the end, we're hoping that computer science can be counted as a math, science, or technology credit versus just a pure elective like yoga. Yeah, so we don't support that, and there's a lot of reasons why, revolving around policy. Like, for example, imagine a teacher who wants to teach Spanish. Are they going to take computer science as well, and how does that work out? Like, I take Spanish and computer science in college so that I can be a foreign language teacher, and then, but all I want to do is teach Spanish. In the same way, if I want to teach computer science, then I have to be foreign language certified, so then I need to take all these other languages, but, So there's different issues around that, but really we're about technology, math, or science credit for computer science. And then the education work, which is the meat and potatoes of code.org. So you might have thought that code.org is only the hour of code and a lot of promotion of computer science. But no, actually the meat and potatoes of code.org is hands-on workshops with teachers and giving them curriculum and helping them feel confident to teach computer science in their classrooms. Whether they're a science or math teacher, elementary school teacher, or a computer science teacher at the high school level, we work with them. So for example, this past year we launched our K-5 program, and up to now I think we've PD'd about 6,000 or 7,000 elementary school teachers nationwide through our affiliate network of about 80 affiliates. And all that professional development is done for free, and not only that, every single teacher walks away with the curriculum, in hand printed, but it's also on the web, and all the materials, including potting soil and pipe cleaners. You'll have to look at the curriculum to figure out what potting soil has to do with computer science. The case for computer science. We know that computing is everywhere. It's even in love, the algorithms that control online matchmaking. But are students getting adequately exposed to a foundation in computer science if it's everywhere? The answer is no. There's a job student gap. On the left side, you'll see a graph that was pulled from data created by the Bureau of Labor Statistics. It shows new STEM job growth this decade, 2010 to 2020, so projected STEM job growth. So out of all these STEM fields, engineering, social science, biology, chemistry, etc., the majority of growth this decade will be in the computing fields. 60% of new STEM job growth this decade will be related to computing, while all other math and sciences combined equate to 40%. Engineering is awesome. You hear a lot about engineering. In fact, engineers are usually the highest paid folks coming out of college. I think the highest paid position coming out of college is a petroleum engineer. They make, on average, starting about $100,000, $105,000. Pretty good for a 22-year-old kid. Computer scientists, depending on what you're doing, could make up to $85,000 starting salary. If you're in cybersecurity, you'll make like $125,000 as your starting salary, and you'll be highly sought after. The issue here is that the education side doesn't match with the job side. So on the right side, you'll see a graph of all the AP STEM subjects, AP Bio, AP Chem, AP, all the AP Psych. Only 2% of AP STEM students take computer science. This is an issue. And so basically, this feeds into the higher ed pipeline, and there are not enough kids graduating in the US with computer science degrees to fill all the need that the US requires. Furthermore, there's a representation gap in the students who are taking computer science, who are graduating with computer science degrees. The graph on the left shows the breakdown by gender for the AP Computer Science test. Year after year after year, the AP Computer Science test shows the worst gender breakdown of all 30-something AP exams. I think there are either 34 or 37 AP exams. The AP Computer Science test shows the worst gender breakdown every single year. This in a time where the AP Computer Science test is actually the fastest growing tests in terms of participation, the gender breakdown is still the worst. And I believe the 18 and 82 was from the 2013 administration. And I think it didn't improve much for 2014. In terms of race, I mean, obviously you guys recognize that that's not representative of our nation. So that's a problem as well, and probably you've heard about all the diversity issues in the tech industry. But the tech industry, the high-tech industry, Google, Amazon, Microsoft, Dropbox, LinkedIn, they're just a sliver of the actual tech industry, the industry that requires tech-educated people like insurance, banking. These industries require way more tech people than Google or Amazon. And there are still diversity issues there. And why are the numbers so bad? Basically, the majority of schools, K-12, don't even offer computer science classes. And furthermore, only 25 of our 50 states count computer science towards high school graduation. I'm not saying they make computer science a requirement. I'm saying they just count it towards high school graduation. Basically, in 25 states, if you take computer science, it doesn't matter. Like, it's basically on the considered the same thing as yoga or home ec or cooking. Actually, in many states, home ec actually counts towards graduation. So that's an issue. So why would a kid take computer science, which is not easy? It's fun, but it's not easy. Why would they take it if it doesn't even help them graduate? That's a problem. And so that's why we do our advocacy work. And that's why we also hold the Hour of Code. The Hour of Code, the whole reason to do the Hour of Code is to expose students to computer science, a little bit of computer science. An hour is not going to make you a programmer, but it's going to at least get maybe light a spark in you. It's also to expose all kids to computer science through a fun, engaging way. I want to show you a video of from the recent Hour of Code that we used to promote it.
Hi, I'm Leah.
And I'm Tanya.
And we're lucky enough to be studying computer science.
Hi, I'm Tanya.
We think it's terrible that 90% of schools don't teach it.
They definitely didn't offer it at my high school.
Thanks.
So we're trying to make this video to show that anybody can learn. We want to get 10 million students to do the Hour of Code.
Hour of Code.
Hour of Code.
The Hour of Code.
Hour of Code.
Hour of Code.
Hour of Code.
The Hour of Code! How do you get him to get to the sunflower? He needs to do some actions.
I got it. Hey!
And then we'll run it and see what happens.
Amazing.
There we go.
You just wrote your first program.
I wrote it?
Yeah. This is the code that you just wrote.
Very awesome.
I thought like code was like FBI hacker symbols and stuff.
A little bit of problem solving, a little bit of logic. It's like instructions.
Programming is a lot easier today.
Don't just play on your phone, program it.
All right.
Awesome.
How does someone go about getting a job?
Maybe take an online class, find a class at a community college. You can get one of the best paying jobs in the world.
I think medicine's moving into the whole computer age.
Technology touches every part of our lives. If you can create technology, you can change the world.
So we're excited that you are participating in today's Hour of Code.
We just did 2 lines of code.
4 lines.
7 lines.
5 lines.
Escribir 25 líneas de código.
5 lines.
60 lines of code.
99 lines.
60 lines. 18 lines of code.
75 lines of code.
Doesn't matter how old you are.
Todos lo pueden hacer.
The hour of code.
Hour of Code.
Yeah, programming a code. The Hour of Code.
The hour of code.
The Hour of Code.
Whether you're a young man or a young woman, whether you live in a city or a rural area,
Everybody in this country should learn how to program a computer.
And I just completed the
Hour of Code.
It's actually really easy to learn.
Girls should learn this too.
Understand that language. That's going to be the future.
anyone can learn computer science. And you can learn too.
Jack Dorsey, Mark Zuckerberg, Bill Gates, all of y'all, I'm learning.
Give it a shot.
Here, now they can't tell me nothing. We give that to the people, spread it across the country. Labels out here, now they can't tell me nothing. We give it to the people, spread it across the country. Here we go.
So we did hit 100 million, and that was our goal. I think 10 million was mentioned because that was the same video we used, I think, in 2013. But for the recent December 2014 week, Computer Science Education Week, in which we hold Hour of Code, we aimed for 100 million, and so we finally hit 100 million, I think, gosh, maybe 2 months ago or something like that, which is pretty amazing. That many folks trying out 1 hour of coding. And obviously a lot of those folks who probably never coded or done anything computer sciencey before. That's quite amazing. And so that's what the Hour of Code is for. It's had international reach. This is not an image that shows who's done the Hour of Code. This is an image of how many places or organizations have hosted an Hour of Code event. An event where it could have just been one classroom of 20, 30 kids, a whole school, or multiple classrooms, or a whole school, or multiple schools. This is a picture showing 7,000-ish Hour of Code events that were registered before the Hour of Code happened this last December 2014. So you'll see that it's really all over the world. It's one of the world's largest, if not the world's largest, learning event, and certainly the world's largest online learning event. Code.org focuses on the US, but there are countries like China, Vietnam, and even Estonia. Skype came out of Estonia. And countries even like Estonia that make computer science widely available at the national level, and even sometimes mandatory or compulsory for kids. And the US is way, way behind. We also featured a tutorial featuring Disney's Frozen, Anna and Elsa, showing kids how to make snowflakes. And we use a block language, which is different than typing code. When you type code, if you forget a capital letter and you use that under a lowercase letter, or you miss a semicolon, your whole program doesn't work. And that's an issue when you're trying to just teach kids how to code. They don't want to get bogged down with the syntax. So we use a block language. And so if you move these blocks and put them in the workspace in a particular way, you get a program out of it. In this case, the program creates a snowflake. And by the way, the Anna and Elsa tutorial is actually not easy. So we didn't make it easy because it's geared towards girls. We still kept the rigor there, but we made it more engaging so that they would be more motivated to complete it. So other than Anna and Elsa, which was awesome this year, I got to go to the White House and see not only the vice president, but also the president code in the same room. And if you know the president and vice president, they don't often do like public things together like that. So that was a very special thing. And here's a picture of the president putting on a Code.org hat and coding. That was really cool. Not only that, Apple, one of our promotional partners, held Hour of Code workshops in all Apple stores worldwide. Last year, they held them just in the US. That was pretty special as well. We had models like Carly Kloss and Lindsay Scott doing video chats with students. Those models code as well. And I'll be talking a little bit more about Lindsay Scott. We've also had lots of schools respond to the Hour of Code by increasing their computer science offerings. We even had one school in Cajon Valley, USD in San Diego, create the world's, well, not the world's, probably the nation's first K-5 computer science magnet school. So having computer science for all grades K-5 is pretty amazing, but creating a whole special school just for that purpose is quite amazing. And I'd like to thank, Apple, Google, Amazon, and Microsoft as well. Microsoft, there was a letter from the CEO to all 100,000 employees at Microsoft asking them to hold Hour of Code events, to go into schools and do events like that. Hey, AV guys, I don't know what happened with the slide. We are working on it. Okay. I want to get into the nitty-gritty of this presentation now. So there are 5 key messages around computer science education. Maybe this is some of this stuff is new to you. If it's not, hopefully it equips you to speak to other people and promote computer science in a way that they can understand. The 5 messages are, number 1, STEM does not equal computer science. Just because there's a STEM offering in a school, you can't count on the fact that computer science is being taught as part of that STEM offering. You would think that the T would mean computer science. I'm going to show you, even at the state level, the T, technology, does not often mean computer science, and that's an issue. Computer science is more than coding. Coding is programming, so kind of like the hammer and nail when it comes to creating a building, but there's much more to creating a building than the hammer and nail. Computer science is much more than coding. They're not the same thing. Computer science is also foundational. It's not just for the kids who want to be programmers, who want to make video games. It really is for everyone. I'm going to make that argument. Computer science is changing the world. Think about even what you're doing right now. You have a laptop in your hand or a tablet. You're taking pictures. You're tweeting. All of these things are made possible because of computing. Lastly, computer science really is for everyone. When I tell you to think of a computer scientist or a programmer in your mind, you probably get some kind of stereotypical picture of a computer scientist. Maybe that person looks like me. Maybe that person looks like, just some nerdy dude. But I'm going to make the case that computer science really is for everyone, and actually lots of different people from other fields use computer science all the time, not just the traditional computer science fields. So let's get into the first misconception, that learning STEM equals learning computer science. I talked about, I showed you that 40-60 graph before. This is the actual graph. It's actually 62%, but 62 looks kind of weird, and a 40-60 just has a better ring to it. But computing occupations will actually represent 62% of new STEM job growth. And if you look at, maybe you look at your degree, I always look at my degree. My official degree was in neurobiology. That's life sciences, and I think that's, I can't even see it. It's like 5%? Yeah, so it's going to grow, thank goodness, but it's going to grow at a way slower rate than the computing fields. And it's not only the Bureau of Labor Statistics, it's the President's Information Technology Advisory Council that has also said, and I'll read it from their study, all indicators, all historical data, and all projections argue that computer science is the dominant factor in America's science and technology employment, and that the gap between the demand for computer science talent and the supply of that talent is and will remain large. While there will be inevitable variations in demand for every field, the long-term prospects for employment in computer science occupations in the United States are exceedingly strong. All other science and technology fields pale by comparison. And I don't mean to degrade anything about all the other fields. It's just that a lot of folks, when they think about STEM, they think about science and math because that's where the focus of our testing is. They don't think about computing. So let's look at a case study. I told you that when you think of STEM, CS is not often included, even when you think of the T. There are 140 objectives or indicators in the Maryland Technology Standards. Anyone from Maryland here? Okay, so there's this thing called the Voluntary State Curriculum for the Technology Credit. Every single high school student, public high school student, has to take 1 year of technology. So you would think, 1 year of technology, every single student? Well, Maryland must be cranking out students who know computer science. Not so. Because of the 140 indicators in the Maryland Tech Standards, the word computer is only mentioned 5 times. I just did a Control F find. 5 times. That's that's kind of troubling. It's more troubling how computer is used in those 5 mentions. So 0 times is computer mentioned in the context of programming. Programming, software engineering, they don't show up in the standards at all. So what that means is that you have all these technology credit courses that have no reason and actually aren't supposed to touch on computer science or programming. So we're going to play a little game to show you how ridiculous this is. And you should probably sit next to someone. So I'll wait till some of you guys who are not sitting next to someone get next to someone, because you just need 2 or more people for this game. I love this game. You know, when I was a kid, I used to play this game a lot in the car. Maybe you played it too. I have 2 variations of this game. It's either called United States or Africa. And I'll tell you why. So basically, I go back and forth with someone else in the car, and we name the different states, all 50 of them. And if you can't think of one in like 5 to 10 seconds, you lose. So either someone wins because someone can't think of a state, or we both win because we get through all 50. It's a pretty cool game because you can either lose, win, or both people win. It's a great game, and I apply that to the continent of Africa as well with the countries. You could apply that to Europe, but Europe is a little bit easier. So we're going to play a game. What I want you to do is go back and forth with your partner and name a way that computing affects your life. For example, me and my friend Karen. All right, here we go. I'm going to say, I get a car. I can travel using Uber, right? That's one way computing affects my life. And she'll say, oh yeah, I find flights on Kayak or Expedia. And then we can just go back and forth like that. So why don't you do that and see how far you go. If anyone is stumped for 5 or 10 seconds, they lose, all right? Go at it. All right, so I want you to think about now how many of those computing applications that affect your life involve someone programming it, involve programming at all. I would say almost all of them, probably. Almost all of them. It's hard for me to think of a computing application without programming, yet in Maryland, and I love Maryland, guys. I worked in Maryland for a long time. I'm from Maryland. But Maryland, when they do mention computing in the technology standards, it's 0 times in the context of programming. So that's a problem. Here's the other problem with the Maryland tech standards. So if you work for the Maryland State Department of Education, maybe you can help me fix this. There are 3 times more indicators for construction and manufacturing than the number of times computing is mentioned. So there are about 16 indicators for construction and manufacturing, and there are only 5 that even mention computing, but obviously the 5 that mention computing don't even do it in the context of programming. It's like one of them is use computers and calculators to collect and analyze data. You can use an Excel spreadsheet for that. That's not programming. So that's one issue. And so just because you see STEM doesn't mean you see CS happening in that class or school. And just because there's a technology credit at the state level does not mean that the technology credit includes computer science. Misconception number 2, coding is the same thing as CS, and it isn't. Coding is actually, computer science is actually greater than coding. There's this new AP course being created. It's called AP Computer Science Principles. It's meant to broaden participation in computing. How is it going to broaden participation and take computer science away from being the worst subject in terms of gender breakdown for all 30-ish AP exams? Well, the idea is to expose students to all aspects of computer science, the creative aspects, abstraction levels of computer science, data, algorithms, the internet, the impact, the global and ethical and social impacts of computing, and also programming. Whereas the current AP Computer Science class, and actually lots of computer science classes in this nation, are all about programming, the AP Computer Science Principles class is about much more than that. So computer science is much more than coding. Computer science is also foundational. And so the misconception here is that it's all about jobs. So yes, I did mention jobs, because jobs is kind of an important thing. If you're a parent, you want your kid, and if you're a teacher, you want your students to get jobs in the future. And there are a lot of jobs in computing available. But computer science is really foundational for all students, not just students who want to be programmers or game designers or create apps or whatever. I'm going to take Lindsay Scott as an example. Lindsay Scott is a Victoria's Secret model. She also models for Gucci and Prada. She went to Amherst, and she majored in both computer science and I think theater. And obviously she chose the more like theater side of things. But she actually uses her coding background, her computer science background, in the field that she's pursuing right now, which is modeling and acting. And so that app on the left is actually an app that Lindsay created. It's called the iPort or iPortfolio. You use it for your iPad. And she created it for her fellow models so that they could create a portfolio on the iPad and show it to prospective clients. She also created a game featuring Ryan Gosling aimed at girls to get them coding. I don't know who Ryan Gosling is, but he's probably some kind of attractive actor of some sort, right? So maybe she knows Ryan Gosling, and maybe it was like a joke between her and him. But either way, Lindsay is a great example of someone who has a computer science background, is not working in a traditional computer science field, but is using computer science to pursue her passion. There are lots of people like this. Computer science is foundational, not just for people who want to go into programming. In fact, I want to describe the difference between the late 20th century understanding of the tech-educated worker and now the early 21st century understanding of the tech-educated worker. Back, in the late 20th century, it was all about using technology. So using PowerPoint, using Excel. And in the early 21st century, it's much more about creating technology and using the processes around computer science for innovating in whatever field you're in. So using, creating. In the late 20th century, it was about information technology, which is a very focused field in computer science. In the early 21st century, it's much more about just computer science as a whole. So not just, so in IT, there's networking, database administration. In the early 21st century, it's much more about how do I use computer science algorithms to, let's say, I don't know, figure out how to get folks through a conference buffet faster. I can, rather than just have it on one side, I can have them go on both sides. So I can use concurrency to my advantage, parallel streams. Oh, wow. Well, I learned about parallelization in computer science. I remember something about multi-threading. Let me just break up this really long table and make it into like 4 tables of 2 sides each. I can get people through this line in, 1/8 of the time that way. That's computer science, and that's for someone who maybe is event planning. In the late 21st century, it was thought of as a vocational field, which means just for folks who are aiming for particular careers. And like I said, it's more of a foundational thing for all folks. Lastly, the late 20th century considered the tech-educated worker as just, a tech worker, and these people go into tech fields. Really, I'm talking about in this early 21st century, folks who are tech-educated who can go into any field. Another misconception, computer science is about cool gadgets and video games, but really computer science is changing the world. I want to talk about computer science for social good. We can get kids creating games, which is wonderful, but what about games that promote awareness around things like the tsunami that happened in Japan about 4 years ago? Ronnie here, in the picture on the left, is presenting about his game that does just that. It's about rewiring a village that lost power during the Japanese tsunami. And there are much more examples of games like that that my students have created. We just had the anniversary of the Selma Bridge crossing just a couple days ago. Well, my students created a game that it's a button mashing game. You just press a button, but the idea is to keep your college student. It's based off of the Greensboro diner sit-ins, and so the idea is to keep a college student at the diner even when the name calling is difficult. And so the name calling gets difficult, you have to press the button a lot faster. Now, a kid could create many games that use button mashing, but by connecting it to a social cause, a social movement, students are learning a lot more. CS can really be for social good. Sherelle created a couple apps as well in her time. She also won an award from the National Center for Women in Technology. She created an app that syncs traffic with your traffic patterns, traffic issues with your errand list, which makes a lot of sense. She also created a role-playing game for conflict resolution. She's now a sophomore at the University of Maryland in the Air Force's ROTC program, and she's majoring in cybersecurity. There are other social causes as well. There are other social cause applications of computer science, things like GoFundMe and Donors Choose, as well as websites like Volunteer Match. So there are examples of this all over the internet. What a lot of kids don't realize, though, is that computer science can be for that social good. It doesn't always have to be for video games and such. And misconception number 5, coders are geeky, nerdy, brogrammers. And while you see TV shows that kind of depict that, like Silicon Valley, the truth is actually different. I've visited Google a number of times, and I see people of all different ages, races, and genders working at Google. Now, they could do a lot better, but it's not like what you see on TV. Computer science really is for everyone, and companies like Google, Microsoft take people from all different walks of life. We at Code.org push to make it known that computer science is for everyone. And the way we do that is we shoot videos depicting people from, who look different than the stereotypical computer scientists and who are from different fields. So for example, Makinde Adiagbo, he's in the top left. He was one of the earliest Facebook engineers. He might be early retired, I don't know, but the last thing I heard about him is he was working for Pinterest. A lot of these folks, a lot of these rock star software engineers who work for these companies early on, like retire at the age of like 32 and then just do stuff just for fun. Usually stuff that piques their interest or for good, for social good. But Makinde is a great example of a person who doesn't look like the stereotypical software engineer. Same with Paula, up there in the third one from the left in Makinde's row. J.R. Hildebrand, he's a race car driver. He talks about computer science and NASCAR. And then we have a gymnast on the right side talking about debugging. And we have Morale on the bottom left, who I believe has a computer science degree. She uses her computer science experience in her dance troupe called Illuminate. So she uses lights and they dance, and there's a choreography based off of the lights, and she has to program the lights. So these are all videos that we have that are available for free through our YouTube channel. And the whole point is to show that computer science is for everyone. And computer science really is for everyone. Here's a picture of kindergartners at Glen Allen Elementary in Silver Spring. My daughter goes there. She's at the top of the G. This is them learning computer science, but not on a computer. This is called an unplugged activity. It's about computing, but not on a computer. They're actually learning about pixels and how pixels are displayed on a screen. All like 90 kindergartners together in the cafeteria. It was pretty crazy, but in the end, they got it. And so, like I said, CS is for everyone, but right now, unfortunately, there is a representation gap. This is the same slide I showed you before, but this is just a reminder of where we're at right now as a nation. At Code.org, we've done a lot of work around improving the representation gap and diminishing it. Currently, right now, in our high school courses, we show about 60% underrepresented minorities. So African Americans and Latinos, the reason why it's so high, that's actually over the nation's representation of African Americans, Latinos. The reason why it's so high is because currently right now we're working in major urban areas. On the other side, you'll see stats that show the breakdown in terms of male, female for our K-5 courses compared to the traditional AP computer science class. So I want to end off by talking about all the resources that are available in the computer science field with a focus on the stuff that we make available for free, Creative Commons and open source through code.org. So Creative Commons means you can take it as a teacher, adapt it as you wish, even spread it around if you want. It's there for you to use. So there are a lot of great resources other than code.org stuff. So I call out a couple right here. There's Google's CS First, which is basically like a club in a box. It's very scripted. All the videos are available. Everything is there. The idea behind CS First is to take anyone off the street and give them CS First and allow them to run an after-school club. So it's a club in a box. Scratch Education, which is based out of Harvard, recently released their Creative Computing Guide for the very famous and popular Scratch programming environment. There's also Scratch Junior for younger kids, early elementary school age kids. That's available on the iPad now, but it's going to be available on Android very soon, and then finally the web. There's groups like Tinker that are for-profits. Khan Academy that also has like a computer science section, some really fun stuff. You learn how to draw using programming commands, a language called processing. And then there are complete programs through Project Lead the Way. They have a K through 12 computer science pathway that they've been developing over the last couple of years. CodeHS is an online platform. Globaloria is a STEM-based computer science program. And then obviously there's the Hour of Code, but we at code.org have a lot more than the Hour of Code. So here's a picture of our Code Studio platform. You'll see 4 courses available for beginners of all ages, starting from kindergarten and up. And then there are the experiences above, like Flappy Code, which allows you to create a Flappy Bird game using blocks. So these are little one-off experiences at the top. And at the bottom, these are like 20-hour-long courses that are both unplugged and online. So unplugged means a computing without a computer, so it's a teacher-facilitated experience. The online stuff looks like what you see right there. This is our K-5 user interface. So you'll see that it involves less text than the interface for older kids. So not only is it block, but you don't have to necessarily know how to read even. And that's designed for kids as young as kindergarten. We have a hint system. There are videos built in. There's also a dashboard for students and teachers. Teachers can see all their students' progress. All of this stuff is available for free, and it's meant to be integrated into the day. For most K-5 classrooms, the way we see implementation is a 1 hour a week for a semester. And that basically gets you through all 20-ish lessons. So 1 hour a week for a semester, that's basically like specials time for elementary school teachers. Told you about Flappy Code. That's what Flappy Code looks like. You just put blocks together and you can create a Flappy Bird game. It's pretty cool, and then kids can even play it on their smartphone, because all of this is available in the browser. So if you have a browser on your smartphone, which most people do, you can use it the same way you do it on your computer. But you can actually touch the screen and play an actual Flappy Bird game that you created. And you can manipulate it if you want. We have lots of video resources that are targeted towards teachers, that allow you to understand a lesson without having to read through the 3 or 4 page lesson plan. That's pretty cool. So a 5-minute video versus a 3 or 4 page lesson plan. There are also videos targeted just for kids, some of the videos that I mentioned before. And so this is just a sampling of some of our videos. So there are a lot of teacher supports here, folks, because my job at code.org as the Director of Education is to give teachers what they need so that they can teach computer science effectively without asking for too much time on their side, because we know that as teachers we have a lack of time. I talked about the whole unplugged and plugged nature of our courses. An unplugged activity is an activity that's teacher-led, not on a computer. It's very kinesthetic and active. And then there are the plugged activities, the online activities as well, that are student-driven and self-guided and self-paced. So these two things interact together. It's a blended curriculum. Now let's talk about science. At the middle school level, we have a computer science and science program that teaches modeling and simulation within the science classroom. It's aligned to the next generation science standards, and you can do it in as little as 5 hours or 25 hours. 5 hours if you just want to do one of the modules. And it covers all three major sciences in the NGSS: Earth, Life, and Physical Science. So this is for middle school students, and this is all curriculum and tool for free available on our website. For math teachers, we have a program called CS and Math, which is built off of, through our partner Bootstrap. Bootstrap is a project that started at Brown, but that's now at Harvard. It teaches it's about functional programming for the purpose of video game design. Functional programming is a little different than the programming that most of us are familiar with. We picked functional programming as our paradigm for CS and Math because the whole point of CS and Math is not the computer science, it's actually the math. So functional programming is a much better paradigm for understanding functions and word problems and algebra. So that's CS and Math. Once again, all available for free, the environment as well as the curriculum. We hold professional development through district partnerships where we actually pay the stipends for teachers, and we don't charge a district for hardly anything, but you do need a district partnership to engage on our science and math PD, as well as our high school PD. But at the K-5 level, if you go to co.org/K5, anyone can sign up for a PD at the K-5 level and go for free. So we have a number of affiliates nationwide. At the high school level, there are year-long courses with full curriculum and professional development. The professional development for these courses are like total about 100 hours of blended online and in-person PD over the span of 15 months, because these are year-long courses. And there are really three pillars around our high school courses: curriculum, professional development, but wrapped around a core of equity. You can talk to me later if you're more interested in that, or visit our website. So what to do now? Because I'm basically at the end and I'm going to take the last 10 minutes to just answer your questions. What to do now? So if you're a parent, ask for computer science. Ask whether your school, whether it's a K-5 school or a high school, ask if they offer computer science. And if they say, yeah, we offer computer science, kids are learning how to type, and they're learning about PowerPoint. Tell them that that's not computer science. If you're an administrator, work to figure out how to offer computer science courses to your students. If a teacher doesn't, if you ask, in the next staff meeting, you ask who knows computer science, who's had any experience in it, and no one raises their hand, it's okay. Our materials are designed for that very teacher. Now, it's obviously a lot better if you have some kind of background at all. You don't need a degree. And I'm sure out of a room of like 50 teachers, you'll probably find at least one that's had some kind of computer science class experience. But if they don't, they're still covered. They're okay. Lastly, if you're a teacher, consider teaching CS by integrating it into your subject. Maybe if you're an English teacher, at least do the hour of code so kids can know about coding. And if you're a science or math teacher, know that we have materials just for you. And obviously, if you're a computer science teacher, you're already teaching computer science, we have even more materials for you. So continue teaching computer science. The key messages behind the computer science education movement. Once again, STEM does not equal computer science. Just because there's a STEM offering in a school or in a state, or if there's a technology credit, does not necessarily mean computer science is being taught. Yet computer science represents the major area of job growth in the STEM fields. Computer science is more than coding. Coding is programming. Computer science is much more. It's data, the internet, it's abstraction and creativity. CS is foundational, so it's not just for folks who want to be programmers. It's also for folks who want to be anything. And I showed you examples of folks who are in different walks of life using computer science in their fields. Computer science is changing the world. Think about Uber, think about the iPad. I mean, you know, the list goes on and on and on. We don't live in the industrial age anymore. We live in the digital age. And it's about time that our citizens from the age of 5 years old understand how to interact and participate in this digital age, not as a user of technology and not as a creator with technology, which is nice though, but a creator of technology. And lastly, and by the way, I want to talk about the industrial age thing real quick. You know, steam engines, it's hard to make a steam engine. You know, there were craftsmen for that. In this day and age, you can get a kid as young as 10 years old creating an app, releasing it worldwide, and making millions of dollars. You can do that. You can't do that legally, unfortunately, because you have to be like 16 or 18 on the App Store, but you can publish it through your parent or whatever. But you can get 10-year-olds doing that. That's absolutely amazing. And lastly, CS is for everyone. 10-year-olds, 5-year-olds, black, white, Latino, whatever. Maybe you don't see that right now in the tech fields, but I've shown you some examples of people who don't fit the stereotype being very successful in computer science. So CS is for everyone. Please participate in the Hour of Code this year. It's December 7th to the 14th, 2015. That's Computer Science Education Week. We hold the Hour of Code during that week because that's a national week. We didn't create that week. I'll take questions now. Yes. Oh, Brent, you'll probably want to go to the microphone.
My name is Brett Wolf. I'm a principal from a rural school district in western Maine. And I came here, part of the reason I came to this session is that I have the opportunity to have a retirement in my math department this year. And because of declining enrollment, I have the opportunity, my goal is to hire a teacher who will have a 6-course teaching load, and I would like 3 of those courses to be computer science and 3 mathematics. I need to, my dream is to hire somebody young and charismatic and vibrant who's gonna and smart, who's going to be able to build a program and inspire kids to want to participate in it. What is your advice about recruitment? We are geographically marginal. We're close to great skiing. And
are you close to Sunday River?
Yeah, well, Sunday River is an hour, but we're closer to the the North Conway area peaks, but maybe we should talk privately, but
sure.
I'm
Check
looking
out
for
the
recruitment.
Computer Science Teachers Association. They probably have a chapter in Maine, send them an email. There's also a job page on the National Computer Science Teachers Association page. And lastly, many math teachers actually have computer science backgrounds. So you're lucky that you're looking for the math-computer science mashup.
Okay, great, thanks.
Hi, my name is Susan. I teach at McLean High School, McLean, Virginia. I'm a special education teacher, and this year we decided to team teach a computer science class. So we have learning disabled children who are not intellectually disabled. They are just lower in processing, and they're working to their capacity. Our problem is we've been doing Java with them, but we can only go so far.
Don't do Java.
because they have no number sense, and so we can only get so far with them, and then they don't get the abstract, they don't get the number sense, they don't see it. So
Yeah, I would look at using App Inventor, which is through MIT, which is a block-based programming language to create apps. You can even put them on Android phones if you want, or a programming environment like Scratch, which is really well supported. And there are lots of other block programming languages as well as ours. It's called Blockly. It's from Google.
Okay, as opposed to like
As
Bootstrap.
opposed to typing out like letters and all that. It's much easier to understand the concepts if you're just working with blocks, because blocks don't allow you to make those mistakes.
Okay, what about Bootstrap? I've heard about that
So
too.
Bootstrap is a text-based programming language right now.
Okay.
We're actually working on a block programming environment for Bootstrap. It's going to be released in June. But that's for math and algebra.
Right.
It's not for just all applications. It's primarily for math and algebra learning.
Okay, great, thanks.
Yep.
So my name's Carrie, and I teach math in Boulder, Colorado. And we have a significant number of English learners at our school. And I'm constantly thinking about, when I studied computer science, there's, syntax as well as, the actual content of what you're programming. And I'm constantly thinking about how you can use computer science to promote language development. And I'm just wondering what you guys have done to partner with, people who are thinking about working with students who aren't yet proficient in English when you're thinking about English-based languages that are drag and drop or text-based.
Yeah, so we actually haven't done much work around crafting resources that to support ELL learners. I mean, what we have done is just translate all of our curriculum and environment into different languages. So you can select different languages, but I wouldn't call that enough support. So we actually haven't done much. I guess that's definitely something that we hear from the community. And in terms of what you're talking about the deeper, like, how do you use coding to actually help the language learning, like learning just language period for kids. And I've heard of research around it, but I couldn't name anything right now. Yep.
Hi, my name is Matt Teeter. I teach in New York City in a very high poverty district. We have 96% free and reduced lunch, 47% English language learners, 93% Hispanic. And I like the whole idea of the paradigm shift. I mean, there has been a paradigm shift from using technology to creating technology. But I think I'm going to bring this back to district leaders or even my school leader and say, we should get away from, teaching the kids how to make a PowerPoint presentation or all the options on Microsoft Word or even making an Excel spreadsheet, and we should teach them how to code. I think they say they need to learn how to walk before they run. And so if they say something like that, is there a compelling argument that can be made if they know how to code, they're going to learn all that other stuff during the process?
They're going to learn it on the way. They're going to learn it along. In fact, I see a lot of schools using computer science and coding as a way to. So oftentimes with students in like high poverty areas, it's all about getting them to level the playing field, right? I see computer science as a way to leapfrog the playing field. So rather than just focus on leveling the play, getting them back up to everyone else's level, the idea is to just totally leapfrog it. And so they will learn along the way. And I can talk to you later about how to craft that argument, because I understand that argument. And one last question.
Hi, I'm Evelyn, and I teach for Prince George's County, Maryland. My question is, now that you have identified the fact that our standards don't include computer considered as part of computer science, have you considered including that, at least like a draft or some suggested standards to complement the curriculum?
Yeah, actually, I'm going to be testifying in front of the state school board in a couple weeks. And PG County, by the way, is one of the districts that we're partnering with this year. So you might want to look for code.org training opportunities in PG County.
Thank you very much.
Yeah, you're welcome. Thank you, folks. I'll be around. We can talk.